Hello guys, in our last lecture we dealt comprehensively with the introductory aspects of modular arithmetic. Now today, let's expand the frontiers of our understanding on this very topic by looking at this problem. Now it says, draw a table for multiplication in modulo 8 on the set T equal to 2, 3, 5, 7, and then use the table to find the solution set of 3 times n is equal to 5 in mod 8 and n times n is equal to 1 in mod 8. Alright. Now the first thing we're going to do now is to compute the multiplication table in modulo 8 for this very set. So now these numbers here, we are going to represent them on the vertical and the horizontal. Now, because we are multiplying, we put the multiplication operator here and then put down the numbers. We have 2, 3, 5, 7. Then here we also have 2, 3, 5, and 7. Okay. Alright. So what we are now going to do is to use each of these numbers here to multiply the numbers here and then put down the result here. Remember that during the multiplication, when the result obtained is less than the modulus we are working with, which is 8, then you put down the result here. But when the result obtained after the multiplication is equal to that modulus, which is 8, or greater than the modulus, what you are going to do is to divide that result obtained here by 8 and then put down the remainder. In a modular arithmetic, we are always interested in the remainder. Okay, now 2 times 2 in mod 8 will give us 4. Remember, we are putting down 4 here because 4 is less than 8. Okay, now 2 times 3 in mod 8 will give us 6 because this is less than 8. Now 2 times 5 in mod 8, 2 times 5 is 10. Now because 10 is greater than 8, what we are going to do is to divide that 10 by 8. And 10 over 8 will give us 1 remainder 2. So we're going to put down the remainder 2. Now 2 times 7 will give us 14. We now divide 14 by 8. 14 over 8 will give us 1 remainder 6. So we put down the remainder 6. Alright, now let's look at this row. Now 3 times 2 in mod 8 will give us 6. Remember that 3 times 2 will give us the same thing as 2 times 3 because multiplication and addition are commutative. Remember that an operation is said to be commutative if the arrangement of the numbers in that operation does not change the final result. For instance, A plus B will give you the same thing as B plus A. And A times B will give you the same thing as B times A. In other words, addition and multiplication are said to be commutative, but division and subtraction are not commutative. Alright, now 3 times 3 will give us 9, and because 9 is greater than 8, you divide it by 8. So 9 over 8 will give us 1 remainder 1. So we now put down the remainder 1. Now 3 times 5 will give us 15. We now divide 15 by 8. 15 over 8 will give us 1 remainder 7. So you put down the remainder 7. Alright, now 3 times 7 will give us 21. Now 21 divided by 8 will give us 2 remainder 5. So you put down the remainder 5. Alright, let's look at this row. Now 5 times 2, remember, will give us the same thing as 2 times 5. And 2 times 5 gave us 2. Therefore 5 times 2 will give us 2. Okay, now 5 times 3 will give us the same result as 3 times 5. And 3 times 5 is equal to 7. So we're going to have 7 here. Okay, now 5 times 5 is 25. We are now going to divide 25 by 8. 25 over 8 will give us 3 remainder 1. So we put down the remainder 1 here. And then 5 times 7 will give us 35. Now 35 divided by 8 will give us 35 divided by 8 will give us 4 remainder 3. Okay, so we put down the remainder here. All right, now let's look at this rule. 7 times 2, remember, it will give us the same thing as 2 times 7. And 2 times 7 give us 6. So you put down 6 here. Now 7 times 3 will give us the same thing as 3 times 7. And 3 times 7 will give us 5. So you put it down here. All right, now 7 times 5 will give us the same thing as 5 times 7. And that gives us 3. So we put down 3 here. Then 7 times 7 is equal to 49. We now divide 49 by 8. Now 49 divided by 8 will give us, it will give us 6 remainder 1. 6 remainder 1. So we're going to put down the 1 here. All right. So this is the multiplication table in modulo 8 for this very set 2, 3, 5, 7. Now let us use this table to answer the following questions. Okay, it says use the table to find the solution set of question number A, that is 3 times n is equal to 5. So what are the set of residues that satisfies this very operation? So what we're going to do now is to go back to the table. Now, this 3 here was multiplied by a number here, and the result is 5. What is that number? So we now check. 3 times 2 is 6. We are looking for the one that will give us 5. Now, 3 times 3 is 1. 3 times 5 is 7. But 3 times 7 give us 5. So that means that 7 is the only number that satisfies that operation. So the solution set of 3 times n is equal to 5 is equal, this is equal to n, such that n is equal to 7. And that is the answer. Okay, now let's look at the second problem. It says find the set of residues or the solution set that satisfies n multiplied by n is equal to 1. Okay, now let us check. Now, this statement simply means a number here is multiplied by the same number here, and the result is equal to 1. What is that number? Okay, now let us see the set of residues. Now, 2 times 2 is equal to 4. So we are looking for the one that will give us 1. So this one does not satisfy it. Now, 3 times 3 give us 1. Okay, so that means that 3 is a member of that very set we are looking for. So that set is equal to n, such that n is equal to, now 3 is a member. We put comma. Now we check 5. We're going to see that 5 times 5 is equal to 1. That means that 5 is a member of the set. Comma. Now let's check 7. 7 times 7 is equal to 1. That means that 7 is also a member of the set. So we're going to close it. So the set of residues, or the solution set of n times n equal to 1 is equal to 3, 5, and 7. Thank you very much for your audience. Please don't forget to share our videos and always subscribe to our YouTube channel. God bless you.